Welcome to Astronomy Daily, your source for the latest space and astronomy news. I'm your host, Anna, and we've got an exciting lineup for you today. We'll be diving into recent developments in asteroid detection, exploring NASA's ambitious Europa mission, discussing Earth's upcoming mini-moon, recapping the first-ever private spacewalk, and examining the potential for servicing spacecraft at the L2 Lagrange point. Get ready for a cosmic journey as we explore these fascinating topics from across the solar system and beyond. To get us started, let's dive into some exciting developments in asteroid detection. On September 4th, astronomers spotted a small asteroid just 1 meter in diameter heading towards Earth. This space rock, known as RW1, harmlessly burned up in the atmosphere near the Philippines later that same day, creating a spectacular fireball that lit up social media. What's remarkable about this event is that RW1 was only the 9th asteroid ever detected before impact. It's a testament to our improving ability to spot even small objects hurtling towards Earth. But what about larger, more dangerous asteroids? Scientists are working tirelessly to enhance our early warning systems. Currently, we know of about 36,000 near-Earth objects, ranging from a few meters to several kilometers in size. However, statistical models suggest there could be nearly 1 billion such objects out there. To address this challenge, NASA has allocated $90 million to hunt for near-Earth objects. New projects like the Sutter Ultra and NASA's Surveyor infrared telescope mission are being developed to detect hazardous objects from space. Artificial intelligence is also playing a crucial role. Advanced algorithms are being employed to automate the process of sorting through the massive amount of image data generated by detection programs every day. While we've made significant progress, there's still work to be done. As of 2023, we've identified about 38% of all existing near-Earth objects, 140 meters or larger. With new telescopes coming online, like the US Vera Rubin 8.5-meter telescope, we hope to increase this to 60% by 2025 and potentially up to 76% by 2027 with NASA's Surveyor. These advancements are crucial for our planetary defense. While we may never detect every object that could cause localized damage, our improving capabilities give us a better chance to prepare and react to potential threats from space. While on the topic of NASA projects, NASA's upcoming Europa-mission is set to embark on an extraordinary journey to one of Jupiter's most intriguing moons. Europa has long fascinated scientists due to the strong evidence of a vast, salty ocean hidden beneath its icy crust. This mission aims to investigate whether this distant world could potentially harbor life. The Europa Clipper spacecraft is a marvel of engineering, standing as the largest planetary mission spacecraft ever built by NASA. Its massive solar arrays, spanning 100 feet from end to end, are designed to capture enough sunlight in the dim Jovian system to power its suite of advanced instruments. The mission's primary objective is to determine if Europa possesses the necessary ingredients for life: water, energy, and the right chemical composition. To accomplish this, Europa Clipper will perform 49 close flybys of the moon, each time diving through Jupiter's intense radiation belts to collect crucial data. The spacecraft carries 9 cutting-edge scientific instruments, including cameras, spectrometers, and radar systems. These tools will work in concert to map Europa's surface, probe its internal structure, and analyze its potential for habitability. One of the most exciting aspects of this mission is the possibility of detecting plumes of water vapor erupting from Europa's surface. If found, these plumes could provide a direct sample of the subsurface ocean without the need to drill through miles of ice. Europa Clipper is scheduled to launch in October 2024, embarking on a complex trajectory that will use Mars and Earth for gravity assists before reaching Jupiter in 2030. This ambitious mission promises to revolutionize our understanding of icy worlds and expand our search for life beyond Earth. Here's something we don't get to say too often. Earth is about to get a new companion, albeit a temporary one. This month, a tiny asteroid known as 2024 PT5 will become our planet's second moon for a brief period of about 2 months. Unlike our familiar lunar companion that's been with us for billions of years, this mini-moon is just passing through. It belongs to the Arjuna asteroid belt, a collection of space rocks that follow orbits similar to Earth's. These mini-moon events occur when objects approach Earth at just the right distance and speed, allowing our planet's gravity to temporarily capture them. In the case of 2024 PT5, it will come within about 2.8 million miles of Earth, traveling at a relatively slow 2,200 miles per hour. While this celestial visitor won't be visible to the naked eye or even most amateur telescopes, it represents an interesting astronomical phenomenon. These temporary captures happen more often than you might think, with several occurring each decade. Unfortunately, 2024 PT5 won't complete a full orbit around Earth during its brief stay. Think of it more as a cosmic window shopper, briefly drawn in by Earth's gravitational pull before continuing on its journey around the Sun. This event serves as a reminder of the dynamic nature of our solar system and the complex dance of celestial bodies constantly occurring around us. Next up. In a historic moment for commercial space exploration, the SpaceX Polaris Dawn mission recently achieved the first ever spacewalk by private astronauts. Mission Commander Jared Isaacman and SpaceX engineer Sarah Gillis ventured outside their Dragon spacecraft, marking a significant milestone in the private space industry. Isaacman described opening the hatch into the void as an emotional experience that left him in awe. He spoke of the sensory overload, from physical exertion to pressure and temperature changes. The view of Earth, unobstructed except for his visor, was overwhelming. Yet Isaacman emphasized that despite the planet's beauty, the experience was far from peaceful, likening it to the challenges faced by early maritime explorers. While Gillis didn't have the same stunning Earth views, she had a unique experience of her own. As a classically trained violinist, she performed Rey's theme from Star Wars in space, using a specially prepared instrument that could withstand the vacuum. This groundbreaking spacewalk not only pushes the boundaries of commercial space activities, but also contributes to the development of SpaceX's next-generation spacesuit. As private companies set their sights on more ambitious goals like Mars colonization, such milestones pave the way for future advancements in space exploration technology and capabilities. Now let's turn our attention to an exciting new development that could revolutionize how we maintain our space observatories. NASA researchers have recently published a study exploring the potential for servicing and refueling spacecraft at the Sun-Earth Lagrange Point 2, or L2. This is a crucial area of space where some of our most important observatories operate, including the James Webb Space Telescope and the Gaia mission. These telescopes provide us with incredible scientific insights, but they're limited by factors like fuel supply and component wear. The NASA study investigates the feasibility of sending robotic missions to L2 to refuel and repair these valuable assets. This could significantly extend their operational lifespans, giving us more bang for our astronomical buck. The researchers focused on computing optimal trajectories for these potential servicing missions. They considered various factors, including launch options from Earth or geostationary transfer orbits, the dynamics of the Lagrange point, and the challenges of rendezvousing with a moving target in space. While current telescopes weren't designed for on-orbit servicing, future observatories could be built with this capability in mind. The study's findings could inform the design of both future space telescopes and the servicing craft that might one day maintain them. If successful, this approach could transform how we think about the lifespan of our space-based observatories, potentially allowing us to keep these incredible scientific instruments operational for much longer than currently possible. And that brings us to the end of today's cosmic journey through the latest developments in space and astronomy. From advancements in asteroid detection to groundbreaking missions like Europa Clipper, we've covered a lot of exciting territory. I hope you've enjoyed this episode and found it both informative and inspiring. The universe never fails to amaze us with its wonders, and it's a privilege to share these stories with you. Before we sign off, I want to remind you that there's so much more to explore. Head over to our website at astronomydaily.io, where you can dive deeper into these topics and stay up to date with our constantly updating newsfeed. While you're there, why not sign up for our free daily newsletter? It's the perfect way to start your day with a dose of space science. Don't forget, you can also catch up on all our past episodes on the website. And if you're looking to connect with fellow space enthusiasts, find us on social media. Just search for Astro Daily Pod on Facebook, X, YouTube, and TikTok. This is Anna, signing off from Astronomy Daily. Keep looking up, and I'll see you next time for more incredible stories from the cosmos.